At 4:13 a.m. on November the 9th, 2025, a faint green arc appeared above the eastern horizon. Amateur astronomers from Chile to Kazakhstan posted the same frame, a thin, glowing streak moving against the background stars of Leo. At first, it seemed ordinary, another long-period comet making its return. Then someone checked the orbit. The object's designation read 3I Atlas, not C 2025 or P 2025. The I stood for Interstellar. It was supposed to be gone forever. After its first recorded pass through the solar system in 2020, 3I Atlas had been declared an interstellar visitor, a one-time traveler from beyond the Sun's gravitational hold. Its velocity relative to the Sun, 32.9 km/s, was too high to remain bound. It came, it burned, it left. Or so we thought. 5 years later, it was back. When the Pan-STARRS telescope in Hawaii confirmed the trajectory, researchers hesitated to publish. The numbers made no sense. An object on a hyperbolic trajectory shouldn't return. Yet the data was clean. Multiple observatories confirmed identical motion vectors. Either the object had never truly left, or it had somehow decelerated and re-entered the solar system. By the morning of November 10th, NASA's Minor Planet Center issued an alert. Potential recurrence of 3I Atlas, subject to verification. No one could explain how that was possible. Comets are time capsules, frozen remnants from the birth of planetary systems. They tell stories of creation, of collisions, of chemical memory. But 3I Atlas was different. Its isotopic ratios, measured in 2020 by the Gemini North Telescope's spectrograph, didn't match any known solar origin composition. It was older than our Sun, possibly 5.5 to 6 billion years old. Its ratio of deuterium to hydrogen suggested formation in a colder, darker molecular cloud far outside our stellar nursery. That meant this object wasn't just a comet, it was a fossil from another world. A relic from before our system even existed. When it first passed through, scientists called it a cosmic refugee. Now, its return shattered celestial logic. No gravitational body, not even Jupiter, could have bent an interstellar trajectory back toward us with that precision. The likelihood of a second interstellar object entering along the exact same path was astronomically small, less than 1 in 10^12. And yet, there it was, visible again through JWST's near-infrared camera as a dim, green-tinted echo in the dark. At 5:42 UTC, data from the European Space Agency's Solar and Heliospheric Observatory, SOHO, revealed something stranger. 3I Atlas wasn't just reflecting sunlight, it was emitting a narrow-band glow near 630 nanometers, consistent with ionized oxygen, but far stronger than any known cometary emission. That light signature had one implication. The comet's material was active, releasing gases or energy in ways we hadn't seen before. But how could a frozen relic from another system still be alive? And what had awakened it again after drifting in the dark between stars? Astronomers compared notes. The velocity had dropped slightly, but undeniably. From 32.9 km/s in 2020 to 29.4 km/s now, it meant deceleration. Something had slowed an object that should have been eternally outbound. Solar drag couldn't do that. Neither could gravity. Speculation ran wild. Some blamed measurement errors. Others invoked the Yarkovsky effect, the slight thrust caused by uneven heating on a rotating body. But to slow a 4-kilometer nucleus by that margin would require a continuous force of hundreds of tons, far beyond known cometary outgassing. Then the silence began. NASA's Near-Earth Object program stopped updating its public tracker after November 11th. The Minor Planet Center's log went blank. Even the Atlas survey, the project that discovered it, posted no new data. For amateur observers, 3I Atlas was still visible before dawn, faint but definite. For official channels, it no longer existed. Here's what we know. A body matching 3I Atlas's signature and trajectory has reappeared in near-Earth skies. Its spectral data suggest renewed activity and unexplained deceleration. Public datasets from multiple space agencies have gone silent since November 11th. Here's what we don't: how an unbound interstellar object could return after leaving the solar system. What mechanism could slow or reignite a billion-year-old body of ice and metal? And why, once again, the instruments turned away just when the sky lit up. At dawn on November 13th, 2025, the Subaru telescope on Mauna Kea caught what many thought was an optical artifact. The image showed 3 separate tails extending from 3I Atlas, not one. A main dust tail, faint as expected, a narrow plasma jet pointing directly opposite the sun, and then a third filament, curved backward, following the comet's path instead of trailing behind it. That shouldn't exist. Cometary tails are formed by solar wind and radiation pressure. They always point away from the sun. A tail that arcs inward means something else is shaping it. At first, scientists blamed instrument glare. Then, data from Chile's Very Large Telescope, VLT, confirmed it independently. The curvature remained. The strange third tail was real and growing brighter by the hour. Spectral analysis added another puzzle. Traces of ionized nickel and complex silicates not seen in natural comet outgassing. The line intensities resembled those of industrial alloys. Metallic bonds broken under heat far higher than a comet nucleus should reach. Was 3I Atlas heating internally? Or was it reacting to something outside our solar environment? By November 15th, an emergency working group formed under the IAU's Small Body Dynamics Committee. Teams from Caltech, the Max Planck Institute, and JAXA pooled early spectrograms. The object's nucleus appeared fractured, not disintegrated, but segmented as though it had opened. In infrared, it pulsed faintly at a period of 41 minutes. Not continuously, not randomly, periodic bursts of heat and visible emissions. At first, the theory was simple: rotational instability. A comet spinning itself apart, sunlight triggering asymmetric outgassing. But the math didn't work. For a nucleus roughly 3.8 kilometers wide, a 41-minute spin would tear it apart entirely. So the question changed. Not what was it doing, but what was being released. When the James Webb Space Telescope turned its instruments toward the region, the near-infrared spectrograph caught something unseen in any comet before. An ammonia signature laced with nitrides, more common in deep planetary atmospheres. Jupiter's, for example, or exoplanets forming far from their stars. That composition shouldn't survive ejection from another star system, yet there it was, fresh and bright, as if preserved in vacuum for eons. Then something else happened, subtle, but deeply unsettling. Between November 16th and 18th, orbital models began diverging. Different observatories plotted slightly different paths. Variations of 0.02 AU, about 300,000 kilometers, a full lunar distance of discrepancy. That might sound small, but in celestial mechanics it's enormous. Objects don't just jump orbits. For a consistent mass and known trajectory, deviation means an unmodeled force, or an unaccounted variable. Solar radiation pressure, too weak, outgassing jets, too symmetrical. Gravitational perturbation, none detected. The data began hinting at a terrifying possibility. 3I Atlas wasn't being pushed. It was responding. On November 19th, ground-based telescopes in Spain and Australia recorded a faint burst of radio frequency noise near 1420 MHz, the hydrogen line, the same frequency used by SETI researchers when scanning for interstellar signals. Coincidence? Probably. Natural plasma interactions can produce narrow-band emissions. But the timing, synchronized within seconds of the comet's infrared pulse cycle, made it impossible to dismiss completely. The public never heard about it. The datasets were flagged as instrumental interference and pulled offline. but astronomers share things privately. One post in an encrypted mailing list simply read, "It's still active, it's doing something." Meanwhile, the brightness continued increasing, fivefold since its reappearance. 3I Atlas was now visible to the naked eye in rural skies just before dawn, glowing with a faint green hue. Observers reported it as eerily steady, not flickering like most comets. The gas coma appeared structured, filamented, patterned, as if magnetic fields were shaping it. Some compared it to C-2023 A3 Tsuchinshan Atlas before its outburst, but the symmetry was sharper, controlled. If it truly was a fossil older than the Sun, what had reawakened it? Was the energy coming from internal reactions, radioactive decay, crystalline collapse, or something external, like solar magnetic resonance? One researcher from Kyoto University phrased it bluntly during a midnight press call. "We might be watching a message written in ice. A process that began before the Sun existed is now finishing before our eyes." The quote never made it to publication. Here's what we know. 3I Atlas now shows triple tails and rhythmic thermal emissions every 41 minutes. Its composition includes unexpected heavy elements and ammonia nitrides, suggesting extreme preservation. Orbital deviations indicate forces beyond solar radiation or known gravitational effects. Unconfirmed reports mention radioactivity near the hydrogen line coinciding with emission cycles. Here's what we don't: the source of its periodic heating, why it slowed and returned to the solar system, whether we are witnessing simple chemistry or something we've never classified before. By November 22, 2025, 3I Atlas had crossed inside Earth's orbital path. An event no orbital simulation from 2020 had ever predicted. Its perihelion should have been 0.63 AU from the Sun. Now, the data said 0.49 AU. It wasn't just returning. It was cutting deeper into the solar system than before. The orbital models broke down. When the Jet Propulsion Laboratory (JPL) recalculated using fresh optical tracking, their integrator software, the same one used for asteroid defense simulations, produced impossible results. Negative delta V residuals. In plain terms, the comet's motion didn't obey conservation of momentum. Every time they corrected the model, the same discrepancy reappeared. At first, it was micro-level, millimeters per second, then centimeters, then full meters. Something in 3I Atlas's path defied the physics that describe all other known bodies. No jet activity, no visible fragmentation, no known drag force could account for it. One internal note from JPL's Solar System Dynamics group leaked briefly before deletion. Equation doesn't close. The mass-energy terms don't match observation. Rerun under anomaly flag. Meanwhile, the European Space Agency's Gaia Observatory noticed something else. Every time 3I Atlas pulsed in the infrared, that same 41-minute rhythm, local starfield brightness values dipped ever so slightly, as if light were being refracted through a changing plasma field around the object. Not eclipsed, bent. The effect was tiny, on the order of 0.04 magnitudes, but statistically undeniable. This suggested that the object wasn't only emitting gas, it was warping the light behind it. Could that happen naturally? Possibly. Charged ions interacting with solar wind can create refractive halos. But the consistency, the timing, and the amplitude matched no known plasma process. It was as if 3I Atlas had surrounded itself with an electromagnetic sheath, a lens of its own making. Then came the spectrographic event of November 24th. At exactly 03:19 UTC, the Infrared Telescope Facility (IRTF) in Hawaii captured a sudden shift in the comet's reflectance curve. A sharp rise in albedo from 0.07 to 0.18 within 6 seconds. The object grew brighter by more than 250%. That kind of change would normally require a massive outburst. Tons of gas and dust expelled at high velocity. but none was detected. No debris field, no coma expansion, no dust spike in the photometric data. The only measurable change was thermal. Surface temperature jumped from 168 K to 201 K, and then stabilized as if it had reached equilibrium with some new internal source. At Caltech, astrophysicist Dr. Leland Ortiz proposed a radical idea during an emergency colloquium. What if 3I Atlas isn't responding to solar energy? What if it's responding to position? He pointed to orbital data that matched his theory. Every emission cycle aligned almost perfectly with gravitational null points, Lagrange regions relative to the Earth-Sun line. The pattern was geometric, not random, almost navigational. Nobody wanted to use that word, but the implication hung over the conference like static: navigation. Still, Ortiz stayed cautious. It may be a relic following physical laws we don't fully understand: crystalline memory, magnetic inertia, ancient matter reacting to space-time gradients. But numbers kept refusing to behave. When the JWST's mid-infrared instrument, MIRI, locked onto the comet on November 25th, it detected something unprecedented: coherent phase oscillations across a 14-micron band. Essentially, organized infrared interference patterns that shouldn't exist in a natural object. To produce phase coherence, emission must come from a synchronized process, like a laser cavity or a lined crystal array. But this was a comet nucleus spinning and venting gas. No alignment should survive. NASA analysts tried to model it as resonance between molecular bonds under solar excitation, but the frequencies were too precise, separated by exact factors of 3.141 MHz, the mathematical constant p, to within instrument error. A random process doesn't output p. That night, independent astronomers in Argentina noticed something that would haunt observers for weeks. The comet's periodic pulses, those subtle 41-minute flares, changed. The interval shortened to 37 minutes and 52 seconds. Each pulse grew slightly redder, shifting toward longer wavelengths. It meant one of two things: either the object was heating from within, or the pulse mechanism itself was evolving. When compared to trajectory data, a pattern emerged. Each pulse coincided with a measurable micro-adjustment in velocity, around 0.08 ms, tiny, barely measurable, but in cosmic terms, deliberate. The interstellar fossil was correcting its course. By November 27th, it passed within 0.12 AU of Earth, roughly 18 million kilometers. For the first time, the comet's ion tail extended visibly across the sky, cutting a thin green blade through the pre-dawn clouds. Radio astronomers listening to the 1420 MHz band reported faint rhythmic fluctuations again, now matching the new 37-minute period. Still, official channels stayed quiet. NASA's public outreach posted only one short line on X: "We continue to monitor interstellar object 3I Atlas. Data collection ongoing." Then nothing. Here's what we know. 3I Atlas's orbit has shifted unpredictably, showing violations of standard momentum equations. It displays refractive plasma behavior consistent with controlled electromagnetic effects. Periodic emissions are shortening and correlating with minor course changes. Infrared coherence patterns suggest structured, synchronized emission from its surface. Here's what we don't. What mechanism produces precise infrared phase patterns? Why its emissions align with gravitational null points? Whether we are observing a natural crystalline phenomenon or a relic performing its final trajectory before vanishing into time. The pulse reached its peak intensity on November 29, 2025. By then, the rhythm, once every 41 minutes, had shortened to exactly 36 minutes, 00 seconds. Observers around the world, from amateur astrophotographers to professional observatories, began to notice something uncanny. The cycle was synchronized to Earth time. Each emission began within seconds of the top of the hour, adjusted by 24-minute offsets, as if some invisible clock in the sky had locked onto our planet's rotation. Coincidence? Possibly. But the consistency defied randomness. Even the European Southern Observatory's cross-correlation analysis found phase alignment between the pulses and the Greenwich Mean Time markers used for satellite calibration. The universe doesn't keep human time. Yet, 3I Atlas suddenly did. When the Solar Terrestrial Relations Observatory, Stereo A, captured new data on November 30th, its coronagraph showed a dramatic transformation. The comet's coma, once diffuse, had compressed into a geometric shell, faintly hexagonal, rotating in tandem with the pulse. That shape wasn't optical illusion. Polarimetric mapping confirmed angular regularity, 6 distinct emission sectors, each about 59.8 degrees apart. Natural. Maybe, but only barely. Crystallization can produce symmetric jets, yes, but not perfect angular segmentation. Dr. Maria Lund of Uppsala University summarized it with professional restraint. If it's natural, it's the most symmetrical natural structure we've ever recorded. Then came the blackout. On December the 1st, the Deep Space Network, DSN, reported intermittent disruptions across its Madrid and Canberra antennas. Narrow-band noise precisely at 1420 MHz, bleeding into telemetry channels used for Mars relay operations. It wasn't strong enough to interfere completely, but enough to corrupt data packets from Perseverance and Mars reconnaissance. Orbiter for nearly 12 minutes. Engineers blamed solar interference, but the timing, the exact moment of 3I Atlas's next emission cycle, was impossible to ignore. At 03:36 UTC, the comet flared again. JWST's instruments saturated briefly, the image pipeline filled with white noise and vertical artifacts. For 2.3 seconds, the telescope's sensors registered a uniform output, a perfect, featureless plateau. Then, nothing. When the signal returned, the comet had dimmed by half. Surface temperature dropped from 201 K back to 174 K. The triple tails dissipated into one, faint and diffuse. To casual observers, it looked like any other dying comet. To professionals, it was as if something had finished. NASA resumed updates, briefly confirming stabilization and reduced activity. But the official tone was oddly final, as if the story were closed. No mention of the coherence bands, no mention of synchronized pulses, just silence. But data doesn't lie. Independent analysts still had cached telemetry from JWST's 2.3-second plateau. And when they examined it frame by frame, they found something impossible. Hidden within the noise, across 4 separate detectors, was a repeating numerical signature, 1.61803. The golden ratio, multiplied in sequential harmonics. At first it looked like a processing artifact. Then, analysis confirmed the numbers weren't random. They appeared across multiple independent instruments: infrared, ultraviolet, and magnetometric. A mathematical constant imprinted across the spectrum, timed with the final pulse. Was it coincidence, a resonance effect, or was it something deeper, a physical constant asserting itself through a process we hadn't yet named? December 2nd brought the quietest sky in weeks. 3I Atlas's glow faded to magnitude 8.5, invisible to the naked eye. The rhythmic emissions stopped. The tail collapsed into a faint arc of dust drifting outward. Yet one detail went almost unnoticed. Gaia's instruments still registered minute light refraction around the former nucleus coordinates. A thin, persistent gravitational signature, even after the visible object had dimmed beyond detection. Something was still there. Not bright, not material, but measurable. Astrophysicists called it gravitational ghosting, the lingering curvature in space-time after a dense mass departs. It usually fades in hours. This one persisted for days. By December 5th, it was still measurable. At a press briefing that same day, a reporter asked Dr. Ortiz the question everyone avoided. Do you believe 3I Atlas was artificial? He paused for a full 10 seconds before answering. I believe it behaved as if it remembered something. Then he walked off stage. Here's what we know. The emissions shortened to a precise 36-minute period before abruptly stopping. Hexagonal symmetry appeared in the Comet structure, verified by multiple observatories. A 2.3-second global data blackout coincided with JWST signal saturation. Numerical patterns resembling the golden ratio appeared in residual spectral noise. Gravitational distortion persists where the comet's nucleus should have dissipated. Here's what we don't. What caused the synchronization with Earth's time standard? Why the geometric emission pattern vanished so suddenly, whether the final pulse marked the end of a process or the start of something we've yet to perceive. By December 8, 2025, 3I Atlas was officially gone. NASA's tracking page quietly removed its active status, classifying it as dormant. The last confirmed image, taken by the Lowell Discovery Telescope, showed nothing more than a faint smudge against the glare of dawn. To the naked eye, it was over, but in astronomy, nothing ever truly disappears. That same night, several radio telescopes continued to record residual emissions, faint, whisper-like frequencies in the hydrogen line, spaced at precise 36-minute intervals, even though the comet itself had faded beyond visual detection. The pulses were weaker now, nearly drowned by galactic background noise, but they hadn't stopped. The object's body might be gone. Its signature remained. At the Max Planck Institute for Radio Astronomy, technicians analyzed 72 hours of continuous data. Each pulse carried a narrow harmonic band, a series of frequencies in integer multiples. When plotted, they formed a ratio chain. 1, 2, 3, 5, 8, 13. It took one intern less than a minute to recognize the sequence. The Fibonacci pattern. Again, it matched the golden ratio harmonics observed in JWST's 2.3-second blackout weeks before. Natural harmonics can appear in magnetohydrodynamic plasma events, yes, but the precision here was absolute. The ratios matched to within 0.04%, too clean for chaos. Dr. Lund wrote in her private log, either the laws of nature are far more aesthetic than we ever imagined, or something ancient is performing mathematics in space. As the comet receded into deep interplanetary darkness, one peculiar effect began manifesting on Earth. Photometric instruments across multiple continents started recording unexplained sky glow. Faint, structured light near 630 nanometers, visible only before sunrise. The glow was weak, less than 1% of lunar brightness, yet consistent in form, a faint arc, low on the horizon, following the same azimuth as 3I Atlas's departure trajectory. At first, it was dismissed as atmospheric scattering, maybe auroral reflection, but the timing didn't fit. Geomagnetic activity was low. The sun's wind was calm. Still, every 36 minutes, instruments in Chile, Namibia, and Japan captured the same dim flash, like a heartbeat echoing through the atmosphere. December 10th, the ESA solar wind analyzer aboard the solar orbiter registered a burst of high-energy particles incoming from a direction just 2 degrees offset from the comet's last known vector. The flux lasted 47 seconds. Composition: heavy ions, nickel, magnesium, sodium, partially ionized, traveling at 31.8 km/s. Not solar wind, not CME debris. Their velocity matched 3I Atlas's previous escape trajectory almost perfectly. Somehow, fragments or emissions continued long after the object's visual disappearance, particles moving as if still under command of a coherent source. Solar physicists labeled the burst Event 2025-317A. Unofficially, they called it the residual. At Caltech, Dr. Ortiz convened a small cross-agency team. He overlaid data from Gaia, SOHO, and JWST's telemetry blackout window, aligning each by time rather than location. What emerged shocked everyone in the room. During the final emission on December 1st, the background star field behind the comet distorted in a specific direction. A measurable angular displacement of 0.003 arcseconds toward the constellation Perseus. In simple terms, when 3I Atlas shut down, it focused something toward that region of space. Not random scattering, not gravitational lensing, directed energy, however faint, moving outward, away from the Sun, toward a distant point 2,000 light-years away. That's where Gaia DR3 lists an unremarkable red dwarf star. 2 mass, J034222001 Plor401021, a nameless point of light with no known exoplanets. Until now, irrelevant. But perhaps the comet knew something we didn't. December 11th, NASA's infrared astronomical satellite, NEOWISE, caught a final glimpse, a residual heat plume at 0.42 AU beyond Earth's orbit. Temperature, 110 K. Shape, elongated, diffuse, yet perfectly aligned with the same Perseus vector. Dr. Lund summarized it in her nightly report. It looks like a signal that refuses to die. But by December the 12th, all instruments went dark again. No more pulses, no residual heat, no ionized particles, just silence. The kind that only deep space can hold. And then, one last data point, buried deep within the ESA telemetry logs. At 0636 UTC, exactly 36 hours after the final pulse, a faint fluctuation appeared in background cosmic microwave data. Frequency shift, 14 for 2400 5 MHz, the same hydrogen line. Direction, Perseus. If the signal was real, it didn't originate near Earth. It came from beyond. Here's what we know. 3I Atlas's physical presence vanished, yet radio pulses persisted for days in 36-minute intervals. Harmonic ratios in the residual frequencies match Fibonacci sequences with extreme precision. Unexplained atmospheric glow synchronized with those emissions. A final burst of ions traced a coherent trajectory toward the Perseus constellation. Cosmic microwave anomalies were detected from the same direction shortly after. Here's what we don't: whether these patterns represent communication, decay, or pure coincidence. Why natural processes would encode mathematical constants so perfectly. If 3I Atlas truly left, or if a part of it now travels where we cannot follow. On December 14th, 2025, the sky over the Atacama Desert was silent. No light traces, no residual glow, no comet. Yet above that emptiness, instruments still whispered. At 02 on 12 UTC, the Atacama Large Millimeter Array, ALMA, detected an ultra-faint microwave fluctuation, amplitude less than 0.3 millikelvin, from the exact coordinates where 3I Atlas had last projected its energy vector, toward Perseus. It wasn't noise. Across the planet, 3 other observatories registered the same pulse within seconds, all in phase alignment. It wasn't coming from the comet's former position. It was coming back from the direction it pointed to. If light took millennia to cross interstellar space, then what had returned in just 3 days? Something local, maybe? Reflection? But the data didn't fit. The delay corresponded not to physical distance, but to cycle time. The 36-minute rhythm again, scaled up to 36 hours, as if the universe itself had joined the pattern. Meanwhile, scientists revisited 3I Atlas's earliest spectroscopic readings from 2020, its first known pass through our solar system. Back then, those ratios of deuterium, nickel, and oxygen had puzzled researchers. Now, a small team at the University of Helsinki ran correlation analysis between the 2020 data and the new 2025 emission patterns. They found something astonishing: the same periodic spacing in atomic emission lines, a harmonic structure buried in the noise. It was there all along. The fossil had carried a rhythm 5 years before anyone knew to listen. One researcher's note, later leaked anonymously, said, "It's not a reaction. It's a recurrence. We just never recognized the clock." In mid-December, a curious shift occurred in public space monitoring data. The Solar and Heliospheric Observatory, SOHO, showed intermittent lens flare artifacts when imaging the Sun's northern limb, but when analyzed frame by frame, the patterns formed a linear interference track consistent with a coherent microwave reflection. Someone at ESA overlaid the trajectory vector. It aligned with 3I Atlas's departure path toward Perseus. It meant one thing: something along that path was still interacting with sunlight, whether dust, plasma, or something structured. It was still there. By December 17th, whispers of unease began spreading among research circles. A classified report from NASA's Planetary Defense Coordination Office, PDCO, leaked briefly to journalists before vanishing, described stable photometric anomalies at 0.117 AU. Meaning, in simpler terms, light that didn't fade with distance. Reflectivity that remained constant, a violation of the inverse square law. That doesn't happen in physics, not unless something is amplifying or redirecting light rather than reflecting it. Dr. Ortiz, speaking in an internal video call that would later circulate online, put it more poetically: it's like a mirror that refuses to dim, a geometry that resists entropy. On December 18th, the James Webb Space Telescope took one last look before 3I Atlas's region passed behind the Sun. The near-infrared camera, NIRCam, recorded a diffuse crescent-shaped glow, cold metallic blue, precisely along the predicted trajectory line. It wasn't dust. Its emission spectrum corresponded to iron silicide, a mineral that shouldn't survive sublimation near the Sun. But instead of cooling, it was heating. Temperature rose from 118 K to 142 K over a 90-minute observation window, the opposite of expected decay. Energy was entering it from somewhere else. Webb's telemetry closed the session with a single annotation. Object exhibits non-thermal excitation pattern inconsistent with reflection or radiative transfer. Energy origin unknown. That phrase, energy origin unknown, quietly disappeared from the public release. On December 19th, astrophysicists convened at the International Center for Theoretical Physics in Trieste. Half the attendees had spent the past month tracking what they called the Atlas residual. Their conclusion was both bold and unsettling. If 3I Atlas had indeed originated outside our solar system, possibly billions of years before the Sun formed, then its composition could include materials with quantum memory effects. Under extreme electromagnetic conditions, such materials might resonate with distant fields, reactivating when exposed to specific solar alignments. In other words, the comet could be a natural recorder, an interstellar time capsule designed not by intelligence but by physics itself. A structure capable of replaying signals from its birth environment. Ortiz objected. But it changed, he said. It synchronized. It aimed. That's not passive memory. The room fell silent. That night, the last ground-based observation of 3I Atlas's trajectory came from an amateur in Namibia using a 12-inch reflector telescope. He captured a faint shimmer in Perseus, a twinkling, rhythmic light invisible to the naked eye. He measured the interval manually. 36 minutes exactly. When he uploaded his finding to an online forum, other amateurs confirmed it. Whatever remained of the interstellar fossil, dust, ions, memory, it was still pulsing, and it was no longer here. Here's what we know. The emissions from 3I Atlas's direction now originate near the Perseus constellation. Microwave reflections, iron silicide heating, and constant luminance anomalies have been observed along its path. The object's pulse rhythm persists across multiple frequency domains. Optical, radio, and thermal, the harmonic ratios match those embedded in its original spectrographic data from 2020. Here's what we don't: whether these echoes are transmissions, reflections, or memory effects in interstellar plasma. What mechanism allows light intensity to remain constant across astronomical distance, and whether the direction of Perseus represents coincidence or destination. By the winter solstice, December 21st, 2025, 3I Atlas had officially passed beyond every telescope's field of view. Yet, across global data networks, it refused to fade. Solar probes, magnetometers, even climate monitoring satellites began picking up faint electromagnetic irregularities, spaced apart, predictably by 36 minutes. It was no longer a comet, it was a pattern embedded into the environment itself. At the European Space Operations Center, ESOC, an algorithm built for filtering telemetry drift detected an odd recurrence. Packets of data, corrupted, seemingly random, kept inserting a numerical code into unrelated streams. In binary form it read 01 111 1111 1111. When decoded, it spelled one word: cosmos. At first, engineers laughed it off. Cosmic ray bit flips happen constantly in space hardware. But then it appeared again, same sequence, across 6 independent spacecraft separated by millions of kilometers. Mars Express, Parker Solar Probe, Juno, all hit by identical interference bursts within milliseconds of each other. All directed along the same azimuth, the Perseus vector. Coincidence? The odds, according to ESA's statistical office, were beyond astronomical. When the anomaly reached Earth-based systems, things turned stranger. The Deep Space Network's Madrid antenna registered broadband static synchronized to the same pattern. After spectral cleaning, a repeating waveform emerged, rising amplitude peaks separated by the golden ratio, 1.618:1, precisely matching the harmonic spacing first seen in the JWST blackout weeks prior. Dr. Maria Lund stared at the printout for a long minute before speaking. If it's random, the universe has a strange sense of aesthetics. The room was silent. Meanwhile, dust collectors aboard the solar orbiter returned their first physical evidence. Tiny grains, likely remnants of the comet's trailing debris, struck the detector array between December 17th and 22nd. When analyzed, these particles displayed an impossible structure. Under electron microscopy, each grain contained microscopic lattices of iron and silicon arranged in logarithmic spirals, identical in geometry to the spiral arms of galaxies. The ratio of turn angles: 137.5 degrees, the golden angle. No known crystallization process produces such symmetry at that scale. One internal memo from ESA described them as self-similar patterns spanning from microns to astronomical units, fractal memory frozen in mineral form. They called it the message of dust. By December 24th, researchers at the University of Tokyo conducted an experiment. They simulated the known composition of 3I Atlas, silicates, nickel, trace ammonia, in a vacuum chamber, subjecting it to solar wind analogs and magnetic oscillations at the same periodic interval, 36 minutes. After 9 cycles, the sample began emitting faint radio noise near 1420 MHz. The hydrogen line, the exact frequency 3I Atlas had used. No circuitry, no mechanism, just heated dust. The implication was profound. Under the right resonance, matter itself could store and re-radiate structured information, not technology, not biology, physics as communication. NASA didn't release any statements for the rest of the year, but an internal JPL report dated December the 26th summarized what few dared to say aloud. The recurring signal pattern cannot be dismissed as interference or coincidence. Its harmonic ratios and geometric periodicity are consistent across independent instruments. Source origin remains unconfirmed. The hypothesis of a natural resonant recording within interstellar material is under review. Buried in the appendix was a short phrase written by hand in pencil. It's speaking the language of structure itself. At dawn on December 27th, something subtle but breathtaking occurred. All sky cameras in the northern hemisphere, from Arizona to Norway, caught a faint, symmetrical halo stretching across the stars, a soft arc of light invisible to the naked eye but clear in long exposure, connecting Orion to Perseus. Inside that arc, a ripple, a shimmering band that moved like a pulse. Period. 36 minutes. It wasn't bright, but it was global. For 2 hours, the sky itself seemed to breathe. And then, like before, silence returned. No one knew whether they had just witnessed physics, memory, or something in between. Here's what we know. Electromagnetic bursts across the solar system now carry identical binary sequences spelling cosmos. Collected dust from 3I Atlas shows microscopic fractal geometry aligned to golden ratios. Lab tests reproduced hydrogen line emissions from replicated cometary material under timed resonance. A faint optical halo appeared globally on December 27th, repeating the same emission interval. Here's what we don't: whether this phenomenon represents intelligent communication or the universe echoing its own structure. How inanimate minerals can retain organized frequency patterns across years and distances, and if the message of dust is a signal to us, or simply a message through us, written long before Earth existed. By the final days of 2025, the rhythm of 3I Atlas had seeped into everything that could measure time. Magnetometers ticked with invisible pressure. Atmospheric spectrometers twitched in lockstep. Even the atomic clocks at Boulder and Paris reported minute synchronization drift, oscillating by 36,002 minutes. Something that no longer existed was quietly pulling the solar system into cadence. On December 29th, the Parker Solar Probe detected a narrow band pulse from behind the Sun, the exact region where 3I Atlas had last aligned its tail before vanishing. Duration: 6.2 seconds. Frequency: 1420 MHz again. Waveform amplitude: consistent with the prior cosmic heartbeat but inverted. It wasn't transmitting to the Sun this time, it was reflecting from behind it. For the first time, scientists could triangulate the signal's precise source. Not Perseus, not the solar corona. A point roughly 0.0014 AU from the Sun's North Pole, a region swept clean of debris and plasma. An empty coordinate. Until now. The heliospheric imager on stereo A caught it first. A glint, tiny, structured, and moving against solar wind. Size: indeterminate, possibly meters across. Reflectivity: 10 times brighter than any known cometary fragment. Trajectory: outbound, on the same bearing 3I Atlas had once followed. It was too small to be the comet's core, too coherent to be dust, and its motion, constant, unperturbed, indicated control, or memory. Dr. Ortiz called it the seed. Whatever 3I Atlas was, it left something behind, a piece of itself, or maybe the part that always mattered. At the same time, back on Earth, the Super Kamiokande neutrino detector in Japan recorded a tiny spike. An energy burst coinciding to the same second as the Parker pulse, a handful of high-energy neutrinos directionally biased toward the Sun-Perseus line. Neutrinos rarely align. They pass through matter untouched, unbent. Yet here they were, in pattern, in sync. No known astrophysical event could explain it. No solar flare, no coronal mass ejection. It was as if the echo had reached every layer of the cosmos, light, matter, gravity, and time itself, and told them to remember. On December 30th, data scientists at the SETI Institute attempted to decode the repeating binary pattern embedded in the earlier Cosmos transmissions. They stripped carrier harmonics, adjusted for Doppler drift, and reassembled frequency modulation into a temporal waveform. What they found wasn't a message, not in language. It was geometry. When plotted in 3 dimensions, the signal described a spiral expanding through logarithmic arcs, interlaced by golden ratio crossbars, a model of equilibrium, an equation that balanced itself across infinity. No start, no end, just the geometry of persistence. Dr. Lund, exhausted, whispered during the final debrief, "It's not talking to us. It's reminding us how everything talks to everything else." That night, northern skies erupted, not brightly but profoundly. A thin, pale auroral band extended from horizon to horizon, glowing in faint emerald tones. Unlike ordinary auroras, this one didn't flicker or wave. It held still, a motionless arc pinned above the world, as if the planet itself were holding its breath. Every 36 minutes, the green faded, then returned, a global heartbeat, perfectly timed, perfectly quiet. From space, the ISS cameras showed something stranger still. The auroral band was not random. It formed a single word when viewed from orbit, a curvature following Earth's limb like handwriting. The letters spelled Atlas. By New Year's Eve, the phenomenon had stopped. The glow faded. The instruments went silent. The hydrogen line emissions ceased. The solar system exhaled. But one last echo remained. At Wire UTC, January the 1st, 2026, the Goldstone antenna received an unmodulated pulse, one single burst lasting 3.6 seconds. No data, no code, just pure energy. Its power, measured at source, was negligible, only enough to light a single street lamp. Yet its timing was exact, 36 minutes x 100 cycles since 3I Atlas's final pulse. The fossil had kept time to the very end. In the weeks that followed, astrophysicists began publishing cautiously worded papers. Some spoke of resonance, natural synchronization between atomic transitions and electromagnetic fields. Others wrote of universal harmonics, where physical constants might spontaneously encode mathematical symmetries. But a smaller group, the ones who had stared too long into the data, said nothing. They only noted that the periodic structures seemed to linger subtly in background radiation, as if something still beat beneath the cosmic noise. A pattern older than the sun, remembered now by everything that listens. Here's what we know. A small, reflective fragment now travels the same vector as 3I Atlas, accelerating steadily toward Perseus. Neutrino detections, radio bursts, and auroral geometry all aligned with the 36-minute cycle. The global Atlas aurora coincided exactly with the final emission window. All signals ceased on January 1st, 2026, after one last synchronized pulse. Here's what we don't: whether the sequence was a farewell, a function, or the final step in a cosmic process billions of years old. Whether the seed, now drifting outward, will ever activate again, or whether, in some deep and quiet way, the sky itself has learned to remember. By February 2026, the solar system was quiet again. No pulses, no auroras, no whispers through the hydrogen line. The interstellar visitor had gone, leaving behind only a scar in our instruments and a rhythm we could no longer hear. Yet, silence is never truly empty. Deep space monitors at Lagrange point L2 continued scanning the Perseus vector, long after public attention had faded. Every week, analysts compared the faint microwave background from that direction with baselines recorded before the comet's return, and week after week the data showed a subtle, steady rise. Not a flare, not noise, just an infinitesimal brightening, a glow increasing by 0.3% per day. No one knew why. It wasn't reflection, it wasn't interference, it was as if something out there had begun to warm. At Caltech, Dr. Ortiz worked quietly on his final paper. He no longer called 3I Atlas an object. He called it a phenomenon of persistence. In his introduction he wrote, "When it appeared, we looked outward. When it pulsed, we listened. But what if the message was never meant for us? What if the act of observation itself completed the circuit?" He theorized that the comet had been composed of self-organizing crystalline material, a quantum memory matrix capable of recording electromagnetic history. Over billions of years, drifting through changing stellar fields, it could have gathered resonance patterns, a geological record of energy itself. When it entered the solar system, the sun's field triggered its playback, and when Earth's magnetic field synchronized, it amplified the memory. Not communication, but remembrance. The universe replaying its own formation through a single wandering fossil. The fragment that observers had named the seed continued its silent escape beyond the heliopause. The Voyager 2 probe, still transmitting faintly after nearly half a century, recorded a peculiar distortion when the seed passed within 1,000,000 kilometers of its trajectory. A brief electromagnetic surge, small but structured. An echo in the same golden ratio harmonics. For 3.6 seconds, Voyager's data stream stuttered, then resumed. Its next message to Earth contained a checksum mismatch, producing a single word when translated from binary error code begin. Most engineers dismissed it as coincidence. Ortiz did not. He wrote his final line. Perhaps interstellar memory doesn't end. It replicates. Perhaps the seed carries forward not a signal, but a law. That order can outlast entropy if even once it's remembered. March 2026. The James Webb Space Telescope turned once more toward Perseus. At the coordinates of the faint warming source, it captured a soft, expanding filament, a halo of pale blue, smaller than a pixel yet distinctly growing. No known star lay there, no record of prior activity. But within that faint light, spectral decomposition showed something extraordinary. A reflection spectrum identical to that of 3I Atlas during its final flare. The same elements, the same structure. Repeating, impossibly, light years away. Whatever the seed was, it had arrived, or awakened. By April, research papers shifted from analysis to philosophy. Scientists spoke less of comets and trajectories, more of continuity. The idea that the universe might archive itself through physical forms waiting for resonance to unlock them. Dr. Land's final statement in Nature Astronomy closed the discussion with calm precision. 3. Atlas may not have been the first to pass through our sky. It may simply be the first we were able to notice. In the end, the story of 3I Atlas became a kind of mirror, not of intelligence, not of aliens, but of recognition. That the structures of thought and matter may share the same mathematics. That every spiral, every ratio, every cycle might be the universe quietly repeating itself. Not to be understood, only to be witnessed. On quiet mornings, astronomers still check the hydrogen line, knowing it's empty, but every so often a faint rise in amplitude appears. One tiny spike just above the noise floor. No message, no meaning, just light remembering the shape it once held. Here's what we know. The final residual emission near Perseus matches 3I Atlas's spectral fingerprint. A faint blue filament, less than 1 pixel wide, continues to expand in deep field imagery. The fragment known as the seed likely exited the solar system and initiated that distant resonance. The mathematical constants within the signals remain identical across all recorded phenomena. Here's what we don't: whether this is the birth of a new natural process or the continuation of an old one, whether the seed carries data or simply the memory of pattern itself, and whether, in another distant system, a sky like ours will one day pulse for 36 minutes, and wonder who remembered first.